In this lecture, we will talk about how to verify a claim based on data, which is a topic known as hypothesis testing in statistics. Some highlights for this lecture. We'll use random number as placebo effect for benchmarking. We'll use a small Excel macro to automate a set of repetitive procedure. We also explain the connection between percentile, percentage, probability, and likelihood. Finally, we'll introduce the very important concept of p-value as a percentile to test a hypothesis. Let's again go back to the cancer prediction dataset. I did not include gender as a risk factor to compare with the other 4 biomarkers in our first few lectures. One reason is it's of a categorical type, whereas the biomarkers discussed earlier are all numerical types. Therefore, it's harder to compare a binary variable with continuous variable. The second reason is it provides a good venue to talk about the notion of testing a claim or a hypothesis based on data. You can pause the video here and think about whether the 2 intuitions we discussed earlier still work for the gender column, which is a binary variable. Obviously, histogram will not work for gender because it's a binary variable. So let's look at the second intuition. We can still sort by gender and use the 2 natural groups to look at the risk level within each group by a simple pivot table. So let me again run a quick pivot table. I would use the gender in the rows area, and I would calculate the average of class Y, which can be interpreted as the risk level for each of the 2 groups. Let me again quickly format this into percentage. Now, if you look at the result, it seems that it indicates gender is also a predictor because among all the patients, the average risk is 43%. For male, which is the one population for the gender variable, the risk is much higher at 50%. For the female population, the risk is a lot lower than 43 at 37%. So can we then conclude that yes, gender influences risk of cancer and female is at lower risk than male? The way I face this question should of course give you pause on a simple definitive yes. If you recall how we use a random number to provide a reference line, you might be tempted to see whether we can also run a similar reference line here. So let's now explore whether this idea can give us further insight. Now, how do I produce a column of randomized gender? Remember in the Make Sense data series, I mentioned we can intentionally corrupt the data integrity by sorting by only one column. So to produce a column of gender that is randomized, what I need to do is just to reshuffle this column alone while keeping all other columns intact, like shuffling a deck of cards. So this can be done by using Excel function rand parentheses like what we have done before. Of course, I'm not going to actually ruin the data set, so I will just copy this column of gender. And I would paste it right next to it. And I would rename it gender reshuffle. And next to it, I'm gonna create the same random column by using the same random function we have used before. Now, if I only choose these two columns and to sort them, notice I only choose these two columns, so when I do sorting, only these two columns, only cells, rows in these two columns would be sorted based on the random number column. So let's do smallest to largest. So notice once we have done this once, every patient will be assigned to a random gender identity. So this column is the true gender, this is the gender reshuffle. And also the way we have done this would ensure that the number of male and females in the gender reshuffle would be exactly the same as the true gender column. So now you can think of this gender reshuffle column as a placebo effect, meaning this column should not have any information regarding the cancer diagnosis because it's simply created by a random reshuffle. So now I will use the pivot table to give the group risk with this gender reshuffle column we just created. But let me first copy the result from the raw data from the true gender column and paste it here for reference. Now remember, we need to go back to the pivot table, make sure we will include our new columns. So this time I'm gonna instead of use the true gender column to group, I will use the gender reshuffle. And notice the results are different from the previous result. And it seems it's making sense because this column is completely a placebo effect. Therefore, when we are looking at them by 0 and 1, provided by this gender reshuffle, the risk level for each group are fairly similar to the overall average. Notice this time I leave the rand function in the column dynamically instead of saving the random column as a set of static values. So this will allow me to repeat the same random gender assignment as many times as we need to produce another placebo effect. This can be done by going to the filter, then sorting. So now once I click on sort smallest by to largest, these two columns selected in filters will be sorted based on the ascending order of this random column, based on the existing value of the random column. So let me click on it. Notice the gender reshuffle column is being reshuffled, but the act of sorting will automatically create a new set of random number. And that's why they don't appear in the ascending order. Make sure you understand this and don't get confused. This random function is actually quite versatile when you know how to use it. There are a number of other ways you can regenerate this column of random number. So if you are using PC, you can simply move your cursor to an empty cell and hit the delete key. So every time you hit delete key, it will produce a new set of random number. Or you can go to formula and click on calculate now. It will also produce a new set of random number. So once we are clear that we have reshuffled, we have reassigned randomly the gender identity to each patient again, we can go back to the pivot table to recalculate based on this new gender reshuffle, what is the group risk. So essentially, we are trying to see a different result from the same placebo effect. So you can do so by go to pivot table and click on analyze and click on refresh. So make sure that we notice that the previous result in the female group, the placebo effect produced a close to 45% in terms of risk. So let's refresh it to see. Now it's 42. So we can repeat this same process a number of times. So again, I will sort this smallest to largest. I'll go back here and then analyze and refresh it. Again, the number changes again. So as you can see, the true female group risk is at 37%, but the reshuffle female group risk varies quite a bit. So a logical next step for us would be, let's try to reshuffle this, say, 100 times, and let's copy the result from each reshuffle out and see what the range of this placebo effect can take on. So let's try to do it manually for a few times. So what I need to do is I need to, again, reshuffle from smallest to largest. Therefore, this column has been reshuffled. I need to go back to filter. I need to go back to pivot table, go to analyze, refresh the result. Now this time, I'm going to copy the value and I will just paste it here as value. So this will be the result for one such random run. So let me do it one more time. I will go back here. I will sort smallest to largest. Make sure this column has been reshuffled. I need to go back to pivot table. Go to refresh. Now we create another placebo effect. I will copy. Instead of copying down here, this time I'm actually gonna use the insert. I will use the insert copy cells, and I will shift the cell down. Now this is the result of the second run. So now this is a perfect place to introduce another nice tool called macro that can record steps of Excel operation and repeat it for you with one click of a button. So let me spell out the set of operation that I want Excel to repeat for us. So for one iteration, I need to go to the random column, sort smallest to largest to reshuffle the gender reshuffle column. Then I need to go to pivot table. I need to click on analyze and click on refresh so that the pivot table result is refreshed. Then I need to go to the pivot table and I will copy the result for the group risk for the reshuffle female gender. And I need to insert that result onto the top of the previous results. So let's now look at how to record those few steps into one click of button. So first you need to go to File, go to Option, go to Custom Ribbon. Make sure you select Developer. Now you will find a new tab called Developer. Now let me show you how to record those 4 steps into a macro. Go to Developer, click on Record Macro. I will name it as Ran Shuffle. Now remember, our step number 1 is to sort smallest to largest on the random column so that our gender reshuffle column would be reassigned. The next step is to go to Pivot Table, click on Analyzed, click on Refresh so that this risk estimate is refreshed. The next step is to copy the result. And the last step is to insert that result on top of existing results by right-click and click on Insert Copy Cell and choose Shift Cell Down. And that's it. That's the end of our 1 iteration. So let me go back to Developer. Let me click on Stop Recording. Now I want to add a button so that the macro that we just recorded will be associated with just 1 click of a button. So you can do so by, again, go back to Developer, click on Insert, click on the button in the Form Control, and I will just place it somewhere here. It would ask you to link the macro that you want to the button, and the one we just recorded is showing up here, so let me choose that one and click on OK. Now let's just try what happened if we click on the button. Notice a new result has been inserted to the top of this column. So this allows us to quickly produce a large quantity of the placebo effects. So let me just run a few quickly.